Okay, I'm going to talk about how STP uh, elects the port roles. Okay, I have a very simple network topology. We're using three switches. We have the switch A, B, and C here. So the election process for the STP works following these brief steps. Is the number one, it needs to select a root bridge. The second is gonna select the root port, and the number three is gonna select the designated port. So what is the how is gonna choose the root bridge? The root bridge will be the switch with the lowest bridge ID. And what is a bridge ID? The bridge ID, it is the priority and the system ID extension, which is a VLAN, the VLAN number, and the MAC address. This topology, I'm using only the VLAN, the default VLAN, which is a VLAN number one. So the default priority for the switches, it is the 32768. That's the value. So the priority for all the switches, the bridge priority for all the switches would be 32768 plus 1. That is a system ID extension because we're working on the VLAN number 1. So the lowest bridge ID for these switches will be the switch that has the lowest MAC address, because all the three switches have the same bridge priority. So which of these three switches has the lowest MAC address? If we see the MAC address starts for the switch number, the switch A has a 00E0, it has a 000, so this is lower than this one. And for the switch number, the switch C has a 00D. So this switch, the switch B, has the lowest bridge ID. Okay, and the next will be the switch C, and then the switch A. Okay, so this is gonna be the root bridge. So I'm just gonna type here the root. So there are some rules on STP, some basic rules, and I just write it down here. It says that all the ports in the root bridge will be always designated port. So these two ports, which is the fast Ethernet 01 and fast Ethernet 02, they will be designated port. Okay, designated port and designated port. Now, the second rule, we just elected the root bridge and the port roles for the root bridge, which will always be designated ports. That means that they will always be on a forwarding state. So the next one, we need to elect the root port. Now, what is the root port? The root port would always be the port that has the lowest path cost to the root. How do you calculate the path cost? The path cost. Okay, very simple. We use on STP some default cost. We have an Ethernet port. The default cost will be 100. For the fast Ethernet, the default cost it is 19. And for the gigabit will be 4, and for the 10 gigabit will be 1, the value number 1. So in this link, the one that is connected switch B with switch A, we have the two ports connected are fast Ethernet, so the default cost is 19. Okay, I'm gonna type here the path cost. So this is gonna be the path cost on this link. Now, for the link between switch A and switch C, they are connected with ports gigabit Ethernet. So the default cost for the gigabit is 4. Okay, is the cost is 4. So the path cost of this link will be 4. Okay. Now, for this link, the one that is connected switch B and switch C, they have a different ports. The root switch is using a port fast Ethernet 02, and the non-root switch C, it is using a port gigabit. So they have a different default cost, but which path cost are we going to use? We're going to use the cost that is the bigger, or the largest cost. In this case, it would be the fast Ethernet. It is 19. Okay. Now, why 19? Why not 4? Because this, remember that these two links are using auto negotiation. So this port runs at 100 megabits per second, and this port will run 1000 megabits per second, but it is using auto negotiation, so this port will run on 100 megabits per second also. So it will use the 19. Okay, so how are we gonna elect the root port? Like I said, the root port will be the port with the lowest path cost to the root. So for this port, if we want to go to the root, we have two different paths. One is running from this to this, so we're gonna use the 19, the path cost of 19. That's one of the options. The other option, you can get to the root port using this path, is the path cost 4, and then the path cost of 19. Okay, so it is 23. That will be the total path cost if we use the link, the gigabit 02 link port. I'm sorry, is gonna cost 23. If we use a gigabit 01, it's gonna cost 19. So which one is lowest? The gigabit 01. So is this is gonna be the root port. Root port. Okay, now for this switch, is going to be the same. It has two paths to get to the root. The first one is through the port fast Ethernet 01, and it's going to use a cost of 19. The other path to the root will use the port gigabit 01, which uses a cost of 4 plus the 19 of this path. So it's going to be 23, 19 through this link, and 23 through this path. So the lowest is 19. So this is going to be the root port. Root port. Oh, sorry. This is going to be the root port. Okay. Now we have another. Following these basic rules, we have that all ports in the root bridge are designated port. Okay. There can only be one root port per non-root switch. Okay, so we already have that here. This is the root port for this switch and the root port for this switch. And every non-root switch can have only one non-root port. The other rule says that the root port, it is always connected to a designated port. So this root port is connected to a designated port, okay, and this root port is connected to a designated port. And the last rule says that there will only be one designated port per link. So in this link, I already have a designated port. In this link, I have a designated port. So what about this link? Okay, we need to choose which one is going to be the designated port on this link. So for this switch, this switch has a root cost of 19 because the path cost to the root is 19. So I'm gonna just type here root cost 19. Okay. And for this one, it's gonna be the same root cost because this switch has a root cost to the root of 19. Okay, so the other, when you have a same root cost, the tiebreaker is gonna be the switch with the lowest bridge ID. Okay, so on this case, the switch with the lowest bridge ID will be the switch number C because they both have the same bridge priority, which is 32,769 because we are in the system ID number 1 of for VLAN 1. And then the MAC address. So this switch has a MAC address of 00E0 and the switch C has a 00D0. So this MAC address is lower than the switch A MAC address. So this is going to be the switch with the lowest bridge ID. So the tiebreaker is going to select the switch with the lowest bridge ID, which is this one. So this is going to be the designated port. Get it here. And as this rule says that there can only be one designated port per link. So we already select the designated port on the link. So this one would be the blocked port. This port will be blocked. Okay, now we can verify this information by entering into the switch and I'm gonna type the show spanning tree. I was going to type show spanning tree VLAN 1, but we only have a one VLAN configured in the switch. So if you can see this, it says this bridge is the root, and the bridge ID and the MAC address is going to be the same as a root ID. This is a default switch priority 32,768, but we are adding the system ID extension for VLAN 1 is 1, so we have a bridge priority of 32,769. Okay, now both ports will always be on designated ports, and that means that they will have a forwarding state. You can see that here. Okay, now we're gonna check the switch C. Show spanning tree. Okay, now the root ID, you can see the root ID, the bridge ID for this one. This is the MAC address, is the same here. Now the port gigabit 01 is going to be the root port. Okay, so this is going to be the root port. And what is the root cost? 19 is the root cost. And the gigabit 02, will be a designated port. You can see that here, and it is in forwarding state, and the default cost is 4, just like it says here. Okay, now let's go to the switch A. And now the switch A, it says that the root port, it is the fast Ethernet 01. See that? And it is a forwarding state with a default cost of 19. The root cost is 19. Okay, this is the root cost. And the port gigabit 01 is in a state of block. It's in a blocking state with it's an alternate port. Well, alternate is for the rapid spanning tree protocol, but you can see that. All right. Okay. Thank you for viewing this video.